The thesis is in the title. For 17 years, the Bitcoin network has been quietly building the largest, most distributed, most flexible electrical load on the planet. Today, what happens when you stop treating that as a problem and start treating it as the most valuable grid asset of the energy transition, and how the same playbook applies to AI? 3 numbers, all from official statistics. First, in 2024, Ireland threw away 14% of its available wind, about 2.2 terawatt hours, roughly 450 million euros of clean electricity, gone. And the cause, per airgrid, is the minimum requirement to keep enough synchronous generation online. That's a flexibility problem, not a wires problem, and the distinction matters because the fix for each is completely different. Second, data centres consumed 22% of Ireland's electricity in 2024, up from 5% a decade ago and heading for 30% by 2030. Third, airgrid's DS3 programme pays for the system, services wind and solar can't provide. Inertia, fast frequency response, ramping, capped at 235 million euros a year. Cheap clean energy spilling on one side, a structurally inflexible load on the other. €250 million euros a year, keeping it stable in the middle. That gap is the virtual power plant opportunity, and Ireland is closer to it than almost any market on Earth. A virtual power plant is a software-coordinated aggregation of distributed energy resources, generation, storage, and flexible loads, dispatched as a single market-facing resource. It is not a building, it is a control system with a balance sheet. First, it aggregates thousands of assets, each too small to play in a power market: rooftop solar, home batteries, electric vehicles, industrial demand response, and increasingly Bitcoin mining and AI clusters. The aggregation layer is what makes any one of them tradable. Second, it dispatches with software. An orchestrator talking to each asset over open standardized protocols. This is no longer a research problem, it's procurable engineering. It reads prices and writes set points in seconds, not hours. Third, it trades like a power plant, bidding into energy markets, capacity auctions, frequency regulation, and demand response, stacking all those streams on the same asset. Stacking is what makes the economics work, because no single stream pays enough on its own. If you remember nothing else, a virtual power plant is not a building. It is a control system with a balance sheet. 3 layers. Top, that's the markets that pay: wholesale energy, capacity, frequency response, demand response, congestion. They settle on different cadences, from minutes down to sub-second. Crucially, the virtual power plant bids into several at once on the same megawatt, which is what makes the revenue stack work. Middle, the brain. The orchestrator ingests prices and demand forecast and writes set points to each asset while respecting its service level limits. It speaks vendor neutral, off-the-shelf standards, procurable engineering, not a research project. Bottom, the assets, colour-coded for the rest of the talk. Green is supply, solar, wind, gas. Amber is storage, batteries. Navy is flexible compute, AI training and batch inference. Orange is the mining buffer, machines that hash when power is cheap and switch off when it's not. The whole loop closes in seconds. That's the difference between a virtual power plant and the old bilateral demand response contract. One is a real-time, market-aware control system, the other an annual interruptibility agreement. 3 converging forces, all here today, none reversible. First, renewables are now the cheapest new build everywhere, but they create sharper net load ramps. That 14% of curtailed wind is what happens without enough flexibility around them. It's not a wind problem, it's an inflexibility problem. Second, building new wires is desperately slow. 4 to 8 year lead times, transformer weights doubled in 5 years. The clearest signal, the largest US wholesale market, cleared its capacity auction at the cap, $329 per megawatt day, 2 years running, a $14.7 billion clearing price. The market is screaming for capacity it can't procure quickly. Third, behind-the-meter resources are scaling exponentially. Distributed solar passed 260 gigawatts globally in 2023, more than double 2021, and demand is exploding. The International Energy Agency projects data center demand to roughly double by 2030, with AI going from 5 to 15% of data center power today to 35 to 50%. The conclusion: marginal capacity is now cheaper to aggregate than to build. That's the unlock. Virtual power plants are not a future tense conversation. North America already has 37.5 gigawatts of flexible capacity behind the meter, the Wood-Mackenzie figure, growing about 14% a year. The US Department of Energy projects 80 to 160 gigawatts by 2030, supplying 10 to 20% of peak demand. 3 quick examples. Octopus Energy's Kraken platform believed the world's largest residential virtual power plant at about 2 gigawatts of vehicles, batteries and heat pumps. A GL in Australia, 1.25 gigawatts today, heading for 1.6. Sunrun in the US, 375 megawatts from 75,000 home batteries across 9 states. Nobody on the picks and shovels side doubts this works. The question for this room is, what asset class do you put on the other end of the orchestrator? That brings us to Bitcoin. The central claim in 4 numbers. First, about 1 zettahash per second of hash rate reached in early 2026. The network briefly dipped below that when Texas miners shut down during winter storms. A preview of the flexibility thesis I'm about to make. Second, about 16 gigawatts of continuous global load, 138 terawatt hours a year, spread across every hour. That's more than twice Ireland's entire peak demand, running every second of the year. Third, my message that 138 terawatt hours is about 0.5% of global electricity. Fourth, 52% of the energy mix is renewables and nuclear. The story that mining is a coal load is years out of date. And the geography matters. Hash rate is spread worldwide, the US about a third, then Russia, Kazakhstan, Canada and more. No single country has choke point control. The dispatch signal is price. Every miner runs the same calculation each block. Is my electricity cheaper than the hash price? If yes, hash. If no, switch off. So the network self-balances around the cheapest power on the planet. A 16 gigawatt, globally distributed, autonomously dispatched, market-aware load. That is the textbook definition of a virtual power plant. The only difference is it's baked into the protocol, not bolted on. The receipt. Riot Platforms, a public miner, 700 megawatts operational in Texas, was paid $33.7 million by the grid operator in 2024 to not mine. The 2023 figure was higher still, distorted by August alone, when Riot took $31.7 million in a single month during the heat wave. More than its mining revenue that month, a miner paid more to not mine than to mine by a system operator structurally short of capacity. That's the receipt. 3.5 to 4 gigawatts of mining is now registered as flexible capacity in Texas, up from 1.5 in 2022, responding in under 2 minutes. Nothing else on that grid can shed gigawatts that fast. 3 programs make it work. A controllable load resource framework that lets the grid dispatch miners like generators, a new contingency reserve service built for flexible loads, and a coincident peak charge that rewards loads for avoiding the year's demand peaks. Easy for mining because pausing the hash costs almost nothing. The grid operator's own chief executive says flexible mining effectively adds renewable capacity and improves reliability. That's a system operator saying the quiet part out loud. 6 operating programs today on 3 continents, from 3 megawatts to 1.2 gigawatts, Bitcoin, AI and hybrid loads providing real grid services right now. Riot Platforms in Texas, 700 megawatts, the audited public company exemplar I just walked through. Crusoe at the Stargate Abilene campus, 1.2 gigawatts, and the most important point here, Crusoe started by mining Bitcoin on flared gas, and the exact same flexible load thesis now powers OpenAI's flagship training campus. The playbook ported from mining to AI in one company in 5 years. Iris Energy in British Columbia, 360 megawatts of hydropower, curtailing on a grid signal. Saluna in Texas, 50 megawatts co-located with a wind farm, ramping with the wind. Gridless in East Africa, about 3 megawatts of stranded mini hydro, the smallest number here, and the most important because mining capital is funding grid build-out where the alternative is no grid at all. And Lansham at Fort Stockton, 1.2 gigawatts, hosting Bitcoin and AI on one site. The common thread, everyone assumes the load is dispatchable. The grid signal is a first-class input, not an exception. That's the architecture this talk is about. 2 things about AI training as a grid load. First, what it looks like to the grid. It's not a flat curve. Each training step alternates compute and synchronization, so the chips cycle on millisecond timescales. Meta published this for its Llama 3 run, a 24,000 chip cluster at about 30 megawatts, swinging by tens of megawatts with dummy workloads injected to mask it. At gigawatt scale, those swings reach hundreds of megawatts and can destabilize the network. Semi-analysis calls it AI flicker, and the North American reliability body has flagged it. Not hypothetical. Second, training is flexible at the job level. Checkpoints every few minutes mean you can pause, migrate or resume with bounded loss. Google has shifted training across time and regions for years to chase clean power. And the killer number for this room, Duke University found 98 gigawatts of headroom for new flexible load on the existing US grid at just 0.5% curtailment a year. That's 50 hours a year in exchange for 98 gigawatts that need no new wires. This is where the flexibility argument gets hard, the honest part of the talk. User-facing inference is latency bound. Chat and voice demand responses in under 100 milliseconds, trading and robotics under 30. You can't tell a customer-facing model to nap because the grid needs frequency response. The service contract breaks. The shape is changing too. Inference used to follow a clean daily curve. Agentic workloads are 24/7, bursty, machine-driven. They flatten the average but sharpen the spikes. The least flexible load on the future grid is, paradoxically, the one that looks smooth. The levers are limited. You can power cap the chips to 60 to 80% for a few percent of throughput and shrink batch sizes. Beyond that, you don't defer, you degrade, because a live session's memory state can't be checkpointed the way a training step can. The trapdoor for this audience, batch and asynchronous inference, behaves like training. Overnight pipelines, evaluations, agents with slack deadlines, all schedulable. Treating inference as one load class is the architectural mistake, because by 2030, inference is about 75% of all AI energy, and today it's the least flexible, unless we re-architect. 5 rows, read across, curtailment response, mining under 60 seconds in firmware, training, seconds to throttle, minutes to checkpoint, user-facing inference, power cap only, no clean pause, batch, seconds, impact of curtailing, mining, none. It's stateless, the next attempt just waits. Training, it slows time to train, a soft cost. User-facing inference, a direct breach of a customer contract. Batch, none within its deadline, restart cost. Mining, negligible. Training, redoing work since the last checkpoint. Inference, not applicable. Batch, negligible. Geographic flexibility is the killer feature. Mining, total, because a block solved anywhere is identical. Training, high. User-facing inference, low. Latency to the user binds it. Batch, high. Cost of curtailment. Mining, $30 to $80 a megawatt hour. Training, 200 to 500 plus. Firm inference, effectively infinite inside the service window. Batch, like training. The takeaway, Bitcoin mining is the gold standard flexible load. AI inherits some, but not all of its properties. So the question becomes, how do you use Bitcoin to backstop the flexibility AI lacks? That's the bridge slide. The reframe, and these aren't lessons for AI to teach you. They're capabilities Bitcoin operators already run and can productize. First, firmware curtailment as a product. Sub-second pause and resume is your reality today. AI customers are trying to build it, you have it. Bake it into an orchestrator and sell millisecond-grade flexibility to the grid and to AI tenants. A new revenue line on the same fleet. Second, a stateless restart is your default. Your fleet has no work in progress to lose. AI is engineering hard toward that through checkpointing. For you, it's just how the machines work. Sell that discipline turnkey. Third, multi-tier hosting, the key architectural point. Your grid connection is a chassis that carries firm, semi-flex, flex, and buffer tiers at once. AI rents the firm tier. You keep the Bitcoin buffer. Same site, 2 revenue lines. Fourth, real estate where the energy is. West Texas, the Permian, Paraguay, the Nordics, North Scotland, the cheap power map of the planet, and exactly where hyperscalers are now searching. You got there first. That's why the super virtual power plant isn't a new architecture. It's where your sites grow to. The growth path? The starting point exists today. Co-located renewable plus Bitcoin plus an aggregator, sub 100 megawatt sites, 1 revenue stream beyond hash. The destination, adding the AI anchor tenant, scales the same architecture to about 500 megawatts on a single substation. It's designed as a 2-quadrant grid resource. It absorbs full power when the grid is long and sheds 70% in seconds when it's short. Exactly what a transmission operator wants in its constraint stack. The build, 300 megawatts of solar, a 200 megawatt wind contract, a 100 megawatt battery, and an interconnect rated 400 in, 200 out. A single orchestrator runs it all, and 4 load tiers ranked by curtailment priority. Tier 1, firm, costs 150 megawatts of user-facing inference, never curtailed, the only tier the hyperscaler contracts. Tier 2, 200 megawatts of training, throttled on the price signal. Tier 3, 50 megawatts of batch, deferred for hours. Tier 4, the buffer cannot and what is 100 megawatts of Bitcoin, first off when short. First on to soak up spilled wind, which lets the renewable partner overbuild by 20 to 40%. The architecture isn't new, the integration is, and that's what unlocks the revenue stack. On the left, what happens when grid frequency falls, 5 steps on 1 clock. At half a second, the battery delivers full fast frequency response. At 2 seconds, mining is gone. 100 megawatts dropped in firmware, and no customer notices because the customer is the protocol. At 10 seconds, batch inference finishes its epoch and pauses, another 50. At 2 minutes, training has checkpointed and paused, 200 more. Beyond that, the campus has shed over 350 megawatts of 500, with the firm inference tier untouched. The ancillary contract is met in full. On the right, the revenue stack, illustrative annual numbers for a 500 megawatt campus. The Bitcoin buffer earns about 45 million euros, mostly from soaking up spilled renewables. The capacity market about 38 million. Avoided curtailment, paid by the renewable partner, about 25 million. Frequency response 15, arbitrage 7, not shown. The AI inference revenue. The anchor tenant, an order of magnitude larger, but not a power market product. The real point, these streams depend on each other. No Bitcoin buffer and the renewable deal doesn't pencil, no firm anchor, no tenant, no battery, the training swings hurt the grid, which is why a single campus, not a fleet, is the right unit. For 2 decades, data centers were treated as a grid problem, a load with no agency, a megawatt that just had to be served. The framing was always wrong. Bitcoin operators proved it. A 16 gigawatt globally distributed market-aware load that's been quietly doing demand response on every grid it touches for a decade. The rails are built, the contracts work, the firmware is shipped, AI is the customer who pays to scale them. The path isn't that AI must learn to be flexible from scratch. It's this. Bitcoin operators already have the flexible load architecture and the cheap power real estate. AI inference is the anchor tenant, and the super virtual power plant is what the site looks like when both share one grid connection. And in Ireland, 14% curtailed wind, 22% data centre demand, and €250 million a year paid for exactly this flexibility, the next step is the most obvious of any market on Earth.